section 6.6. We're going to be talking about discounts and markups. This is something that should be easily to understand. Discounts are basically a decrease in the original price. You generally see that with sales and coupons when you go to the store. Markups, generally you don't see this. This usually happens behind the scenes. It's where they increase the original price. And most of the time it's to increase a profit. Case in point, a store will buy an object, say for $100, but they sell it to you for $120 so they can make a profit, all right? That's basically how Walmart and every store works. Matter of fact, that's the exact same thing that we do here at school when we are running fundraisers and stuff. We'll get the materials we need, but we sell it for more than what we bought it for in order to create a profit. Something that's more likely seen, probably especially, is in tax. So when you go to the store, you buy all your stuff, there is a sales tax that they will charge you. So that's just some basic concepts that we just easily understand. Now, how do we go about doing that? There's two big things that we're going to be talking about in this video. First, it's finding the new amount after a change, finding out how much something costs after we do a discount or after we do the markup. And the way we need to do that is first we have to find the physical change. So we can use the A equals P times W from previous sections. And then once we know what that real physical change is, we either add or subtract to the original number. Case in point, if I had something on sale for 20% off, I need to find out what that 20% actually is in real money, not just a percentage, but real money. And then whatever that real physical change is, I subtract it from the original price, okay? And it's the opposite when it's coming to addition. And then we have something that's a little bit more complicated, and we'll talk about this one in just a second. Let's go ahead and do some more with this particular price. So we have an original price here, and it says that the original price is $20, but there is a percent of discount for 20%. So in order for me to find my sales price, I need to find my physical change. So I'm going to kind of do a little bit of work on the outside. I'm going to go A is equal to my percent as a decimal, which would be, we'll do that in a minute, times my whole number. So let's plug things in. A is equal to my percent as a decimal, which is 0.2, times my whole, which in this case is going to be 20. So let's find out what that is. We have 0.2 times 20. That gives me that A is equal to 4. This is the physical change that I'm getting. So it's actually taking off $4 from my original price. So now I can just say I'm going to go 20, which was my original, take away that physical change of 4, and I get that my sales price is actually going to be $16. All right? Let's do 2, just to do some more practice together. Same concept. I have an original price of $95, but there's a percent discount of 35. So I'm going to go A is equal to P times W again, which we can rewrite as A is equal to my percent in decimal form is 0.35 times 95. Let's see what that gives me. 0.35 times 95, that tells me that I have a physical change of $33.25. So this is what my physical discount is. I can subtract that from 95. 95 minus the 33.25, and I get $61.75. Okay? I'm not going to do 3 and 4 just yet. We're going to come back to that one. Let's go ahead and try 5, 6, and 7 together. So this is the opposite. This is the selling price. So it says the cost to the store is $20, but there's a 15% markup. So it's the same concept as before. We're going to use this equation again, and we're going to find my physical change through the markup. So my percent is 0.15 times 20. When I plug that in my calculator, 0.15 times 20, I get 3. So this 3 is my physical markup. They're going to charge me an additional $3. So the cost to the store was 20, but they're going to charge us 3 more. So the cost to us, overall cost, is going to be $23. This is my selling price, okay? Let's try 6. Same concept. The cost of the store is $56, but they're going to mark this thing up 80% markup. That's a huge markup, which actually happens fairly often, by the way. And let's find out what that is. So we're going to go 0.8 is my decimal times 56. Let's see what the actual physical change is. It's $44.80. So they are actually going to add $44.80 to the cost of this item that I'm going to buy. So I'm just going to add that to the 56, and I get that the actual cost of what I'm going to have to pay, the selling price, is going to be $100.80. All right, that is the physical selling price that I have to pay. Well, why don't you try number 7 on your own? So, for number 7, if you were looked at it, you would have a physical change of $150. Your physical markup is $154. So the selling price, whatever object you're buying, is $264. Okay? Now, let's go ahead and start looking at another direction here. This is where it gets a little bit more tedious and a little bit more complicated because we're having to work backwards. Notice in this particular thing, it gives me the sales price and it gives me the percent of discount, but my job is to find the original price. All right, so we have to work backwards in this particular case. There are a lot of different ways to solve this problem, and this is probably why it's the most confusing to do, is to work backwards. But I'm going to try to make this as simple as I possibly can. I will tell you this: if you find a method by just playing with numbers that you seem to like better, come find me. Let me see what you're doing, and if it's a method that is viable, we'll use it. So in this next piece, this is where it gets a little bit more difficult. This time I'm giving you a sales price and a percent of discount, but I'm asking you to find the original price. And this is where it gets a little bit more difficult for a lot of people, is because you're having to think backwards. So I'm going to try to show you what I find to be an easier method. This is my personal way of doing it. Like I said, there are actually multiple ways of doing this, but this is my personal way of figuring out. If you don't like this method and you know of another way, or you pick up another way of doing it, please let me know and let me check it out. And if it's a good way of doing things, then I'm absolutely fine with it. Because like I said, there are a lot of different ways to solve some problems. It's just all a matter of how you determine to do it. With that said, let's go back to that first set of notes, and I'll kind of give you something. Finding the original amount, knowing the new amount, and the percent change. That's what we've got to do. This is the first step that gets really confusing, is finding the real percent. All right? That's a strange statement, but I'll tell you what, I'm going to show you what I mean in just a second. If there is a discount, we're actually going to subtract the percent from 100. If there's a markup, we add the percent to a 100. So and then after we do all that, we use a basic formula that we've known before, the percent proportion, where A is the cost, W is our original cost, and then P represents our real percent. So let me explain to you what I mean by that. So in this particular one, it says that, I'm going to set up a little bit of a proportion over here to the side, and it says that my sales price is $55.50. That's my cost. That's how much I am going to pay. My job is to try to find the original price, which we'll leave as W according to our notes. And then this would be 100. This statement here is where a lot of confusing happens, and I'm trying to simplify this. The real percent. If it's a discount, it says I'm going to subtract the percent from 100. So what I'm going to do is I'm going to say 100 and minus, whoops, already just gave the answer, minus 75 gives me 25. This is the real percent. Now that we have everything in there, we basically cross multiply and divide like we always do. So we can multiply this. We're going to go 55.5 times 100 gives me this large number, 5,550 equals 25 times W when we cross multiply that. Divide by 25 and we get that the original cost of this item was $222. All right, so number 4 is the same way. I'm running out of room on my paper. I want to set it up. I need to use my cost, which is going to be $78. That is my selling price. I'm trying to find my original, and my percent of discount is going to be 40%, so I need to find the real percentage. So I'm going to go 100 minus 40 gives me 60. And then this would be over 100. So to go back into it, this is my selling price. This is the original price that I'm trying to find. This is my real percentage. This is how much that I'm actually trying to work with every 100. Cross multiply and divide, so 78 times 100. Divide by 60 gives me $130. So the original cost on this was $130. All right. Now, I do not have this on the paper, but you can write this down. This is some extra problems here. This is the same concept. I have a cost to store, and we're trying to find it, and this is what I know. I know it's a 25% markup, and I know the selling price is for $437.50. So I'm going to set up that proportion again. I am trying to find the cost of the store. Basically, I'm trying to find the original cost. I know that the selling price currently is $43,750. This is how much they're making me pay. I'm trying to find out how much the store had to pay. And what we also know is that this will always be over 100. And so now we have to find the real percent. Because of our little rule, it says if it's a markup, we add. So in this particular case, the real percentage is 125. Now it's just a matter of following it all out. $437.50 times 100. And now we divide by the 125 because we're cross multiplying and dividing. And we find out that the store bought their item for $350, but they're now selling it to us for $437.50. So that is their markup, so they can receive their profit. I'm going to do this last one with you. All right, so again, we're trying to find the cost to the store, knowing the selling price and the markup. So the cost to the store is $585. We're trying to, their selling price is $585. Their cost to the store, we don't know, but we do know that their real percentage is 130, and this will be always over 100. Why 130? Because it's a markup. Now that we have that, it's just a matter of cross multiplying and dividing again. 585 times 100 equals, divide by the 130. And we find out that the store is bought an item for $450, but with their 30% markup, they're charging us $585.00. All right, so hopefully that kind of helps you out a little bit. It is a little bit on the complicated side. We'll take a little bit of time on this particular section and getting as much practice on this and understanding when do we find a percent discount versus a markup. So we'll use some more practice on this one. Now, let's do this last problem. It says a store buys an item for $10. To earn a profit of $25, what percent does the store need to mark up the item? So this one's is a little bit different than everything we've done, but we can kind of think this one through. The store buys it for 10 bucks, but they want to earn a profit of 25. So if they're trying to earn 25 more dollars, that means that they are actually going to sell it to us for $35. So this is how much they're going to make us pay. Their cost was $10, and so now we can use that same concept to use our percent proportion, okay, that we've used before. All right, now it's just a matter of cross multiplying and dividing again. 35 times 100 equals that, divide by 10, and what we get is 350%. Now, is this our actual answer on this? Well, no, not really. Think back. Now, we did all of this work and we got 350%. This is a markup, so we're having to work backwards. Remember that if a markup, or add the percent to a 100. So what we actually did is we found the real percent, the actual real percentage of what it was from the original. So what's the difference? It's a difference of 100. So the actual physical markup is 350 minus 100. So the physical markup, the actual percentage is 250%. All right. So hopefully that kind of helps you out. Again, I know this one's probably a little bit more confusing because there's a lot of moving parts in there. It's basically asking you to take everything you know about percents that we've covered and applying it in different modes and in different ways. And that's it for this video. I'll see you in the next one. Bye-bye.